Before you scroll away, imagine this. Europe building its first orbital return capsule, France testing a reusable spaceplane, a fusion rocket that could reach Pluto in under 5 years, and a Mars orbiter that gives astronauts internet across another planet. These aren't sci-fi dreams. They're real machines being built right now. And today, you're about to see the 7 revolutionary spacecraft that will change the future of space travel forever. Trust me, once you see number 1, you'll never look at space the same way again. The European Space Agency's future space transport ecosystem outlines a modern, reusable, and highly flexible framework for how Europe intends to operate in space in the coming decades. Developed under ESA's Future Launchers Preparatory Program, this ecosystem focuses on creating an interconnected network of reusable launch vehicles, orbital refueling infrastructure, space tugs, and standardized docking systems. Together, these components are designed to provide Europe with continuous, affordable, and adaptable access to orbit and deep space. A central objective of the ecosystem is to move away from single-use launch models and instead establish modular, service-based logistics. In this vision, spacecraft would be able to refuel in orbit, swap payload modules, extend mission lifetimes, and undergo maintenance without needing entirely new launches. Programs focused on propulsion efficiency, rapid booster recovery, high-performance engines, advanced materials, and disruptive technologies all contribute to creating the backbone required for reusable European spaceflight. At the core of ESA's concept is Odyssey, an orbital servicing and refueling hub designed to store propellant, host maintenance operations, and support spacecraft preparing for missions to the Moon, Mars, or deeper regions of the solar system. Odyssey enables in-space assembly, inspection, repair, and logistics, making long-duration missions far more feasible and cost-effective. By uniting reusability, innovation, and modularity, ESA's future space transport ecosystem aims to reduce costs, increase mission frequency, and position Europe as a global leader in sustainable space logistics and next-generation orbital transportation. The Sunbird, developed by Pulsar Fusion, is an ambitious nuclear fusion propulsion concept aimed at transforming the future of interplanetary travel. Designed around a dual direct fusion drive system, Sunbird combines high-efficiency propulsion with onboard power generation, creating a compact engine capable of supporting long-distance missions without relying on traditional fuel or solar energy. Acting as an orbital fusion tug, the vehicle would rendezvous with spacecraft in low Earth orbit, attach to them, and provide the powerful thrust needed for deep space journeys. Engineers project that Sunbird could deliver roughly 2 megawatts of total output, supplying both continuous acceleration and substantial electrical power for advanced instruments, scientific payloads, or communication systems. Its expected specific impulse, between 10,000 and 15,000 seconds, is far beyond the capabilities of chemical or electric propulsion, giving it the ability to push spacecraft of around 1,000 kilograms to the outer solar system. Firefly Aerospace's Blue Ghost lunar lander represents a significant leap forward in commercial moon exploration. Developed for reliability, precision, and long-duration performance, the lander is designed to deliver scientific and technological payloads directly to the lunar surface under NASA's Commercial Lunar Payload Services (CLPS) initiative. Blue Ghost manages every phase of the mission, from departing Earth to entering lunar orbit and conducting surface operations, using systems engineered for strong communication links, efficient power generation, and stable thermal control in harsh lunar conditions. The lander produces more than 400 watts of power through its solar arrays, supplying energy to a suite of instruments that investigate lunar dust dynamics, surface material properties, radiation effects, and advanced navigation concepts. Its propulsion system provides controlled descent capability, enabling a soft and accurate landing on diverse lunar terrains. Robust thermal management allows Blue Ghost to remain functional throughout extreme temperature swings on the Moon. Advanced imaging systems capture visual data throughout the mission, supporting navigation and ensuring the safe release and operation of scientific payloads. Built with scalability in mind, future Blue Ghost missions are planned to explore additional lunar regions, deploy small rovers, and contribute to infrastructure needed for long-term human and robotic activity on the Moon. The Vortex spaceplane from Dalt Aviation represents one of France's most ambitious efforts to develop a fully reusable vehicle capable of operating both in orbit and within the atmosphere. Designed as a hybrid between an aircraft and a spacecraft, Vortex is intended to support a wide range of civil and defense missions, including launching payloads, servicing satellites, conducting orbital inspections, and returning safely to Earth for runway landings. This approach combines the precision of advanced aviation with the performance required for spaceflight. The development plan for Vortex follows a structured roadmap. The first major step is Vortex D, a 1/3 scale demonstrator built specifically to test critical technologies such as hypersonic reentry, flight control systems, and thermal protection materials. Insights gained from Vortex D will guide the creation of larger versions, Vortex S, Vortex C, and Vortex M, which will progressively expand capabilities toward cargo transport and eventually crewed missions. A key advantage of the Vortex concept is its modular architecture, enabling rapid reconfiguration for different mission profiles. This includes orbital servicing, satellite retrieval, and repeated transport between Earth's surface and low Earth orbit. With durable heat shielding, aerodynamic control surfaces, and full reusability, Vortex aims to significantly lower launch costs while increasing operational flexibility. Supported by France's Ministry of Defense and developed in cooperation with the European Space Agency, the Vortex program has the potential to set a new benchmark for sustainable, multi-mission European access to space. Blue Origin's Mars Telecommunications Orbiter, MTO, is envisioned as a major advancement in how future missions communicate between Mars and Earth. Designed to function as a dedicated communication relay, the orbiter will support the growing number of spacecraft, landers, and rovers expected to operate across the Martian system. Built on the versatile Blue Ring modular satellite platform, MTO incorporates advanced communication hardware that enables continuous, high-bandwidth data transfer. This allows information to flow reliably between Mars orbiters, surface missions, and mission control on Earth. The orbiter is equipped with multiple steerable high-rate antennas capable of delivering focused, long-distance links, along with a broad-beam transmitter providing wide-area coverage. To extend its reach even further, MTO works in coordination with compact UHF relay satellites designed to connect directly to rovers and landers on the Martian surface. CLEAR is a visionary initiative dedicated to developing sustainable human habitats beyond Earth, marking a bold stride toward the future of space colonization. Its mission is to overcome the immense challenges of long-term space living by merging advancements in energy systems, life support engineering, and material science to design self-sufficient habitats capable of sustaining human life on the Moon, Mars, and even deeper into the solar system. At the heart of CLEAR's approach is sustainability and resilience. Each habitat is designed around closed-loop ecosystems, where resources like water, oxygen, and waste are continuously recycled. This not only reduces dependence on Earth, but also mirrors the natural balance found in our planet's biosphere. Power generation relies heavily on renewable energy sources, such as solar arrays and nuclear microreactors, ensuring stable and clean energy supply, even in the harshest extraterrestrial environments. The project's structures are built using advanced lightweight composites and regolith-based materials, providing radiation protection, thermal stability, and durability. These innovations enable habitats to adapt to extreme conditions, from the lunar surface's freezing nights to Martian dust storms. CLEAR's mission goes beyond engineering. It's about creating livable or thriving communities in space that can grow, innovate, and sustain themselves. By integrating artificial intelligence, robotics, and green technologies, the initiative envisions a future where humanity can responsibly expand beyond Earth without repeating the environmental mistakes of the past. The Atmos Phoenix capsule is an innovative re-entry system designed to safely bring cargo back from low Earth orbit, offering a new solution for returning scientific samples and experimental materials to Earth. Its most distinctive feature is its inflatable atmospheric decelerator, combined with an inflatable heat shield. These structures expand during re-entry, dramatically slowing the capsule, reducing thermal loads, and shielding sensitive payloads from extreme temperatures. With a payload capacity of about 100 kilograms, Phoenix is tailored for returning materials science experiments, biological samples, and in-orbit technology demonstrations that require analysis on the ground. The first prototype, Phoenix 1, launched on SpaceX's Bandwagon 3 rideshare mission. During the flight, it successfully deployed and inflated its heat shield under genuine atmospheric re-entry conditions, transmitting critical telemetry throughout descent. Although the prototype was not intended to be recovered, the mission verified the performance of its major systems, including inflation mechanisms, thermal protection behavior, and communication hardware. The next evolution, Phoenix 2, will introduce additional capabilities such as onboard propulsion for controlled descent, increased payload mass, and more advanced communication systems to enhance mission reliability. This upgraded version is being designed for full recovery, enabling routine return of cargo from orbit. With Phoenix, Atmos aims to create Europe's first dependable orbital return service, supporting scientific research, commercial manufacturing, and industrial applications that rely on microgravity environments.